Hi everyone, welcome to another video. This video will be a comprehensive step-by-step guide to indexes in a database. Now I have already created an indexes video on my channel. I will leave a link to that in the description. It goes over the basics much more than I will in this video, although the first few minutes I will give you a general understanding of what an index is and how you create them and what are the different types of the indexes. And then we will move to the second part of the video where I will talk a little bit about pros, cons, and different indexing strategies. So now let's get started. First of all, what an index is. I have a whole video that explains this concept in detail, so I will leave you a link in the description. For the purpose of this video, we need to know that an index is a tree-like data structure that takes the values from the columns that you put into it, puts them into this tree data structure, to allow for much faster querying at the cost of slower writing to the table and at the cost of additional storage. For all examples in this video, I will be using the following data model where we have the customers table that is referencing the orders table and then the products table, and then orders and products tables are referencing the order items table. I will leave you a link in the description for the SQLs that is used to create these tables and insert some test data into them. I'll be using SQLite in Visual Studio Code, so I will be connecting to the database using this extension. And then if you want to follow along, you can just say Python import SQLite 3 and then SQLite3.connect database.db or whatever name you prefer. And this is how you have your database created. So now what I will do is I here have the file that creates the tables and inserts the data. I will just mark everything, select everything, press Ctrl+Shift+Q, and then it will execute it on the database.db. So if you have never done it before, it will just ask you for a database beforehand. And that's how we have our testing set up, where we'll be running all the examples in this video. So to create an index, it's very simple. You just say create index and then the index name. So let's say IDX customers email on, and now a table name. So I'll just say customers, maybe split it into multiple lines. And now in parentheses, the column or columns that you want to use. So I'll just now do this and execute. It has been created. If we want to use it in a query, so I will now just remove it. I will just say select star from customers where email equals, and I will select one of the emails that I have here. So this query will now execute and we get some results. Over here, we have one person. Most likely an index was used here, although of course we can't really see it because we have just a few testing rows there. So in terms of performance, there will of course be no difference visible to us. You can also have an index on multiple columns. So just say create index IDX, let's say customer email phone on customers, and now here email, comma, phone. Ctrl+Shift+Q, and now it's been executed. An index has been created. And now a very important information is basically, if you want to use this index, your query needs to have at least an email in it. So it cannot just have a phone. If you just have a phone, in most databases, this index will not be used. So you either can have an email only, or the best is to have an email and a phone. Our index can also be unique. So I will just say here unique, and you have to say create unique index, Ctrl+Shift+Q, and it's been created. So basically a unique index is a constraint, and that's another function of an index. It can be used as a unique constraint on the table. So now we cannot have a combination of email and the phone that exists more than once in our table. Now there's another option of indexes, which are clustered and not clustered indexes, or clustered and not clustered tables based on this index. So essentially what that means is a non-cluster index is just a normal index that we create. Now a clustered index is an index that defines how the data from the table is saved on disk. So if you define a clustered index, or you cluster a table by an index, as we can see here in Postgres documentation, because it's very important that this is now different in different database management systems. So Postgres treats it a little bit different, SQLite treats it different, and then Oracle and DB2 treat it differently. So this is very important to understand the differences and always refer to the documentation. Basically, nobody has it in their mind. Everyone has to look this up at some point. So a clustered index in general is an index that defines in which order the data is saved in disk. Obviously, there can be only one such index, and you can treat this as this master index for a table. You can also create indexes on the results of the function that you use here on the column. So basically, in order to do this, let's create another one. Let's say here, let's keep on the email, and let's say that you want to query the email very often with an uppercase because, I don't know, you want to, these are your logins and you want to log in some clients to your database, right? So you would just say on customers upper email and then execute this, and an index will be created. Very important is that now, basically, the more advanced the features get, the more differences we will see between different databases, and you always have to refer to the documentation of a selected DBMS that you are using, because here, for example, with the function indexes, you will see a lot of constraints that you have to adhere to. Basically, not always you can use these. Now, in my opinion, these are the most important features of any indexes that are present in most common DBMSs. And basically, there are some small that I didn't mention, like for example, an index can contain nulls, an index can be sorted ascending or descending, but this you will find in my video, my basic video that I did on the indexes, so I will just refer you there. And there are also some super specialty features like Postgres relatively not that long ago introduced something called partial index. So basically you would define a where clause on an index and that it would index only part of the table. But this is something that doesn't really have that many use cases. I feel like, of course, in some special situations can help us, but I will just not cover this. I will just refer you to the Postgres documentation. It's usually pretty good. So if you want to learn more about these, you should go there. There's one more specialty feature I would like to tell you about, and this is an option to include some non-key columns on an index. Basically, let's say that we created an index on the blue column and its values. So we have an index looking like that. We can say include, and then usually in parentheses put some column names, although for specific syntax you need to refer to the documentation. And then the values of the columns that we will include will be put directly on an index, supporting an access method called index-only-scan, because now if we say we want to select C, or the columns, we want to select the values from the green column where the values on the blue column are equal something, for example like 3, we'll be looking for 3, which is here. We will find, okay, 3, and then we will directly have the value C here. So we will not have to go to the data. So we will remove one step that you would otherwise have to do. It can be a difference if you are planning to retrieve a lot of data from an index, because then if you are trying to retrieve, I don't know, thousands or hundreds of rows for some reason using an index, this is not really what an index is designed to do, but maybe you have a use case for this. You can just include this particular column directly on an index, and then you don't have to go to the disk, to the table basically, which can greatly improve the performance of your query. For some pros and cons of indexes. The pros are definitely faster reads, no questions asked. So if you have a big table, millions, hundreds of millions, billions of records, and you try to find a few records from this table using a table scan, which is an access method that reads all the records, it's going to be a dramatic experience in cases if you define an index on it. The definition of an index will probably take some time if your table is very big, but it will definitely be worth it because then your read will be very, very quick. It's also possible to ensure that some values are unique in the table, which is definitely also a pro using the index. Now, what are the cons? Slower writes. And this is a very, I would say, not controversial, but debatable topic. As in, they are definitely slower, but the main question is how much. So you should definitely not be looking at it like if you define one index, it will all of a sudden, like inserting or updating or deleting a record will all of a sudden take twice as long. But you should be looking at like 10-20% because it very much also depends on the number of indexes that you have already on the table, on the size of your index. So if you include many columns, if there are many key columns on the index, it will just take more time. And it must not always be linear. So it must not always be that your inserts, deletes, or updates slow down by 10-20%. It may be that some of the writes are not even affected, and sometimes they will just take much longer because, for example, the index underneath must be reorganized. This just depends on the database engine that's managing this. And of course, indexes take space. The larger your table, the larger the indexes. And the more columns you include, the more key columns you have, of course, also the larger the index. This is why, in general, I would promote an approach with quite eager indexing. However, always look at the fact that they also take up space, and you should not really create ones that are not used. Now for the most important topic, how to create a good index. There will be no definitive rules in this video, don't expect that. I will just give you some guidelines that I'm usually using when thinking about the indexes. So the first guideline is, it usually cannot be done just by looking at the data model. It means that just by looking at a data model like this, I cannot really tell which columns will be good to index. Of course, here on the logical model, we have some primary key and some foreign keys defined, but these are not necessarily created in the database. They can be, and they usually are good candidates. So if you take a look at a field that is a primary key on a table, it is usually a good candidate to index. It can, for example, in certain situations help you with some joins between the tables, so you might look at the relations, especially for a nested loop join. And if you want to know what a nested loop join is, I will leave you a link where I explain different join algorithms in the description. However, here, if you take a look at the primary keys, these are usually good candidates to index, and many companies would have just guidelines that the primary keys or the logical primary keys should be created in the database. So this basically means that they are an index, because a primary key created in the database is nothing else as a unique index that cannot contain null values. Guideline number 2, it is the most important how the data is used, meaning how the data is queried, how the data is used in joins, and how often it is done also. Because if you just have a query that is executed very rarely, maybe improving performance of this query is not something you should be looking at. But if you want to know how the data is used, you have two options. You can either understand the functional use patterns, so you can know what the data that you are working with is used for, how is it queried by the programs that are accessing it, how is it queried by the users that are accessing it, and you can then define the indexes based on the most common queries like this. Or what you can do, but this is a little bit more difficult of a technical option, usually databases will give you a mechanism that is able to track what queries were executed. Very often you need to install some other components to the database, but many databases have a component like this that is able to save the queries that were executed, and then based on the logs that are generated by these components, you can analyze it retroactively and create the indexes for the where clauses that are the most present in the queries. Third guideline, as few rows selected as possible for every key columns combination, meaning the best index is a unique index or a primary key index that returns for every combination of the key columns always only one record, and all indexes that return more are somehow worse in this area. This does not mean that you cannot create indexes that select more rows. You obviously can, and very often you should, but you should think about if the columns that you are including in an index, or so the key columns that you are putting in the index are increasing the selectability of this index. So for example, if you have a column where all the values are the same, you should probably not include it in an index. This also depends on your data. So let's say you have in our customer table, we have an isActive column, which is set 0 to every record for a client that is not active, and 1 for every record for a particular client that is active. So one client will have always one record with isActive 1 and can have many records with isActive 0. And now, if we basically have tens of thousands of isActive 0 records, then it maybe makes sense to include this isActive, right? Because then, if we don't include it and we filter for a specific client from our database, we will get these tens of thousands of records. But if we have only few records for every client, with only few with isActive, and we would include it, then essentially we would get these 5, 6, 10, 15 records, and it really doesn't make a difference if we include this isActive or not, because then filtering through 10 or 15 records takes essentially no time, while if we had to filter through these tens of thousands of records for every client, this could still take a significant time, right? This is why it does not always depend only on the data model and only on the usage patterns, but here it also can depend on the data that you have in the table. This is everything I wanted to share with you on top of the previous video I created about indexes. If it helped you in any way, please leave a comment and share it with your friends. Thank you for watching today, and see you in the next videos.